Yeah, hi everyone, it's Mr. Mark here again. In this video I'm going to go through a few examples of how to write expressions from a worded problem or from a sentence, and also how to evaluate expressions. Now, just looking at the key ideas here, most of these dot points I've covered in my previous video, the language of algebra, so I won't go over those things again, but I just want to draw your attention to these bottom two dot points about evaluating expressions. Okay, and we're going to focus again on expressions today rather than equations at this stage. It says here, expressions can be evaluated by substituting a number for a pronumeral or a variable. So we know a pronumeral or a variable is the letter that's used to represent an unknown value. For this example, we're actually giving that variable, that pronumeral, numerical values. In this case, a equals minus 2. So in the expression a plus 6, we can substitute 2 in for a, and it becomes minus 2 plus 6. Minus 2 plus 6 is, of course, 4. So we can evaluate expressions that way. Just while you're doing that, though, the second dot point tells us that we need to still follow the order of operations. Okay, and if you remember that from perhaps primary school or early year 8, we're talking about brackets first, then powers or exponents, multiplication, division, and finally addition and subtraction. Okay, so let's work through these examples, and again, I've got some questions up on DayMat. These examples will be related to those questions up on DayMat for my class anyway. So you can see here example 1. When you look on DayMat, the question there that has a little rectangle next to it that says example 1, this is the example that's going to help you there. Okay, let's look at example 1a. Now it says, write an expression or an algebraic expression for the following. So for A, it's got the number of tickets needed for 3 boys and R girls. So we're writing an algebraic expression to represent the number of tickets. For how many people? Well, for 3 plus R, or 3 plus an unknown value. Okay, mathematically we talk about plus. So the expression there is simply just 3 plus R. Okay, 3 boys and R girls. We don't know how many girls, so we're representing that with an R. Okay, moving on to example 1b. The cost of pea pies at $3 each. So we're talking about mathematically, multiply. Okay, so pea pies. We don't know how many pies, so it's pea pies. At means times, and they're $3 each, so p times 3. Now, if you remember back to the algebra or language of algebra video, we wrote this term with the coefficient in front of the variable. So 3p. Okay, or 3 times p. You wouldn't usually put that dot there. Sometimes a dot, again, mathematically is represented by multiplication. And I'll get to that later. But 3p is the expression for the cost of pea pies at $3 each. Okay, moving on to example 1c. And it says here, the number of grams of peanuts for one child if 300 grams of peanuts is shared equally among C children. So we don't know how many children. It's represented by the letter C. Shared equally, we're talking about division. So it's 300 grams of peanuts shared equally or divided by C. C is the variable to represent the amount of children. Algebraically, again, we would write this as a fraction. So 300 over C rather than 300 divided by C like this. Okay, so this is how you write an algebraic expression based on that sentence for example 1c. Okay, let's move straight on to example 2. It's got some similar stuff here. It's converting words into expressions. So let's start with example 2a. It says 5 less than x. Now less than, mathematically, subtraction, so 5 less than x. So because it's less than x, x is first, and it's 5 less than. So it's actually 5 less than x. Not the other way around. It's not 5, take x. This would be x less than 5. Alright, so we're not looking at that expression. It's x take 5 is the expression represent 5 less than x. Okay, moving on to B. Example 2b. 3 more than twice x. Now this could be a little bit trickier. So 3 more than twice x. Twice x we're going to represent as what? 2 times by x, or just 2x. And 3 more than that, more than would be plus 3. So there's an expression for 3 more than twice x. Okay, let's go ahead and move on to C, example 2C. Now this is where we're getting a little bit more trickier still. The sum of A and B is divided by 4. We know the word divided. We can write that as a fraction. The sum means add, addition. So the sum of A and B is divided by 4. Okay, so write that as a fraction, and that's your expression to represent that worded problem there. And let's move on to D. So 4D, sorry, example 2D, the square of the sum of x and y. So again, the sum of means to add, so we're going to have x plus y, and the square of. So that means we're squaring the sum of those two variables. So put them in a bracket and raise to the power of 2. Okay, so there you have it, guys. Example 1 and 2 to help you write expressions based on some worded problems. The third example we're going to go through today is substituting values into expressions. We spoke about this just before, and what I'm going to do, I'm going to start by rewriting this example 3a. So it's 7a, take away 2, a take c. Now we know mathematically or algebraically 7a means 7 times by a. I'm going to represent that by a little dot. I'm not going to put a little multiplication sign in here. I'm going to put a little dot because I don't want to get you confused with little x's. So 7.a or 7a, 7 times a. Now likewise, on the right hand side here of this expression, I've got 2 brackets a take c. Now the operation happening in between the 2 and the brackets is again multiplied. So it's 2 times a take away c. Alright, with that in mind, I'm going to go ahead and rewrite these expressions, but instead of a, I'm going to put the number 5, instead of b, I'm going to use minus 2, and instead of c, I'm going to use the value 3. So 7 times, instead of a, I've got 5, take away 2 times by, in brackets, a is represented by 5, and 3, 5 take 3. Okay? Now, order of operations first. Let's go ahead and do what's inside the bracket. So, 7 times 5, you can wait there. Take away 2 times in brackets. 5 take 3 is 2. Now, I've just got 7 times 5 and 2 times 2. 7 times 5 is 35, and 2 times 2 is 4. So 35 take away 4 gives me 31. So evaluating that expression, 7a take 2 times by a take c, when the value of a is 5 and the value of c is 3, is 31. Okay, I'll do the second example, and then you guys can get onto DayMap and have a go at those questions. So example 3b, I'll rewrite that expression again. So b squared take ac. Remember, ac means a times c. So let's go ahead and substitute those values that we know. B is represented by minus 2 squared. Take away a, which is 5 times 3. Now minus 2 squared, that's minus 2 times minus 2. If you put that on your calculator, just like that, you'll probably come up and say minus 4. If you want to do it on your calculator, put it in a bracket. Okay? Because it's minus 2 times by minus 2. We know a minus times a minus is a positive. That actually gives us 4, not negative 4. Okay, be wary of that. And over here, we've got 5 times 3, which is 15. Okay, final step, 4 take away 15 is minus 11. Okay, guys, hopefully that helps. Have a go at those questions on DayMap. If you're not sure about anything, send me a message and I'll try to get back to you as soon as I can. If you're not in my class, thanks for watching anyway, and hope this helps with your maths at school. Thanks, guys.